like humans respond to changes in the environment, so do plants. Tropism is growth in response to a stimulus. Plants respond to both light and gravity. The hormone auxin helps coordinate these responses. Auxin can either promote cell elongation or inhibit it. If we look at phototropism, which is growth in response to light, we can see the following. The shoot tips will show positive phototropism, which is growth towards light. Here's how it happens. Auxin is distributed evenly across the shoot tip if light is all around it. If the direction of the light source changes, auxin moves towards the side of the plant away from the light. It causes this side of the plant to grow faster. As this side of the plant is growing faster, it becomes elongated and the plant moves in the direction of the light source. The root tips, however, will show negative phototropism, which is growth away from light. This is because the shaded side will have more auxin, but instead of causing it to grow faster, it will slow down growth. So the root tips will grow away from the light source. Gravitropism or geotropism, which is growth in response to gravity. Gravitropism can be both positive and negative. In positive gravitropism, you have growth towards gravity, and in negative gravitropism, you have growth away from gravity. The shoot tips show negative gravitropism, and auxin distribution causes the plant to grow against gravity, whereas the root tips show positive gravitropism, and auxin distribution causes the plants to grow in the direction of gravity. Here's how it happens. Auxin accumulates in the lower part of the root tip. Auxin will slow down growth, causing the upper part of the root tip to grow faster, bending in the direction of gravity. Scientists such as Darwin carried out simple experiments to research the detection system of phototropism. He used coleoptiles, which is a sheath that protects the first leaves of cereal seedlings. Because they have a simple structure and are easy to grow, they are often used in experiments of tropism. Darwin set up 3 coleoptiles: an intact coleoptile, a coleoptile with the tip removed, and a coleoptile with the tips covered. He found that in the coleoptile with the tip removed, it showed no growth or bending. In the coleoptile with the tip covered, it showed growth but no bending. The intact coleoptile grew in the direction of the light stimulus. His experiment showed us that the stimulus of unidirectional light was detected by the tip of the coleoptile. Between 1910 and 1926, scientists began to look for the chemical messenger that was responsible for phototropism in coleoptiles. In this first experiment, a mica sheet was placed through the tip, or a gelatine block was used. With the mica sheet, which is a mineral that is insoluble to water, there was no response to the light source. But the coleoptile with the gelatine block, which is soluble, showed growth in response to the light source. This showed us that the chemical messenger was soluble in water, as it was able to pass through the gelatine block but not the mica. In the second experiment, the tip was removed and placed on one side of the coleoptile. What scientists found was that the bending occurred without a unidirectional light stimulus. In this third experiment, the tip was removed and placed on an agar block for several hours. The agar was then placed on one side of the decapitated coleoptile. Scientists again found that bending occurred without a unidirectional light stimulus. The second and third experiments showed the following. The hormone that will cause the bending stimulated growth on the side of the coleoptile away from the light. The chemical hormone, which we now know as auxin, diffuses from the tip down the shoot. If the light is all around the shoot, or it's in darkness, the auxin diffuses equally. If the light is coming from one direction, then the hormone moves to the side away from the light. Over the years, several plant hormones have been found which influences plant growth, such as gibberellins, cytokinins, abscisic acid, and ethene. A clinostat is a rotating device that negates the effect of any directional stimulus. So when plants are grown on these devices, they will grow neither up nor down, but straight outwards in whichever direction they were placed, as the effect of the stimulus has been cancelled out by the revolving clinostat. Hi, my name is Mr. Science, aka Salim. If you're new to the channel, please remember to like and subscribe, and for more teaching resources, you can visit my website at www.mrscience.co.uk.